So we have an exponential function y equals a to the x, where a is any constant, and we want to find the derivative of this. So we do know what the derivative of ln of something is. It's just 1 over something. So we can rewrite this as log base a y is equal to x. Remember, that's the same thing as a to the x equals y. So then, to use the natural log derivative, we can use the change of base formula. So we change the base to e. So we have the ln of y over the ln of a. That's the same thing as log base a of y. So all of this is equal to x. And then we can move the ln a to the other side. So we have ln of y is equal to ln of a x. And then we can use implicit differentiation. So the derivative of ln of y is 1 over y times dy dx. And then ln of a is just a constant. And so the derivative of a constant times x is just the constant. So we have ln of a on the other side. Well, then we can move the y to the other side. So the derivative dy dx is equal to y ln of a. And then if we look at our original function, y is the same thing as a to the x. So we have dy dx is equal to a to the x times ln of a. So if we have any exponential function, a to the x, where a is the constant, then the derivative will be a to the x times ln of a. And so the function y equals e to the x is a special case of this, where a is equal to e. So the derivative of e to the x is, so a is e, so a to the x ln of a becomes e to the x ln of e. But the ln of e is 1. So the derivative of e to the x is itself e to the x. So now let's look at some examples. So we have y equals pi to the x tangent x power. So here, what is a? A is pi, and it's being raised to the power x tangent x. So the derivative of a to the something is a to that something times the ln of a. So we have pi to x tangent x power times the ln of pi. And then from the chain rule, we have to differentiate that something, x tangent x. And to do that, we have to use the product rule. So I differentiate the first term first. So the derivative of x is 1. So then we leave the second term alone, tangent x plus x, derivative of tangent, which is secant squared x. So that's our final answer. So next we have the derivative of ln of cosine of e to the x. So we have 3 functions here. The outside function is the ln of something. So the derivative of ln of something is just 1 over that something. So we take the whole inside cosine of e to the x and put it on the bottom under 1. So our first term is 1 over the cosine of e to the x. And then moving inside, our second function is the cosine of something. And the derivative of the cosine of something is negative sine of that something. So here the inside is e to the x. So our next term is negative sine of e to the x. And then our most inside function is e to the x. So the derivative of e to the x is just e to the x. So if we wanted to, we could simplify this more. Since the sine of e to the x divided by cosine e to the x is the tangent of e to the x. So a final answer would be negative tangent e to the x times e to the x.